number 3 in assignment number 12. So right off the bat, I know that this needs to be turned into just pounds so that I can put in my free body diagram. So I know it's pounds feet, and I know the amount of feet that take up this moment. So I just multiplied 6 feet by 200 pounds feet so that the feet would be crossed, and then I'd just be left with pounds. So I get 1,200 pounds, excuse me. And now that I know this, I can plot my free body diagram to get this whole thing started. So I have 1,200 pounds right in the center there, 600 pounds where it already is, and then I apply an RA right here and then an RB right here. So to solve for RA and RB, I'm going to do the sum of forces in the Y first, which gives me RA and RB as positive because they're going up. 1,200 and 600 negative. So I'm gonna move those to both. I'm gonna sum those up and then move it to the other side so that I'd be left with 1,800 on the other side. Then to find out one of these values, I take the moment about. I could have done the moment about A or the moment about B, and I could have gotten rid of one of them, but just now I decided to do the moment about A. That would give me RB, and then I could eventually solve for RA. So I do that, -3, 1,200, because 1,200 is 3 feet away, and finding the moment, it's gonna be clockwise, which makes it negative. Then the same goes for -9 and 600 because it's 9 away, and then the 600 will make it going clockwise, which is also negative. And then RB is going the opposite way, counterclockwise, so I know that's going to be positive, and it's 12 feet away. So I sum that up, I move everything to the other side, and I get a value of RB is equal to 750 pounds. So then I just plug that back in over here. I subtract 750 from both sides, and I get an RA of 1,050 pounds. Now, I need to find the forces going through each part. The shear forces. So I know that VA is going to equal RA, so it starts at 1,050. And then I just bring in this 1,200 right here because it's going through this to get to C. So then 1,050 minus 1,200, it's gonna equal -150. So I draw a line going all the way down to -150 pounds. And then nothing's being applied over here from C to D because 600 is right on D, so it stays constant until D, at which then it goes to the already found value of 750. So then that jumps to 750, and then it goes to 0. And then let me just flip it here. And then, as you can see, I know that the moment about A is 0. I know that the moment of C is gonna equal 2 times 1,050 added to 600, that gets me 2,700. And then 2,700 minus 450 is gonna equal 2,250. Now for my max stress here, I needed to find I, but I forget that it should be inches, excuse me, it should be pounds, feet. So these values are in inches, so I decided I would convert these to feet instead of inches, which I do here. I use this value and then I plug these values into that, get 10.09, and then divide the height by 2, and then plug all of that in to get 559.3 pounds feet squared.